We're going to now look at a couple of questions dealing with determining angle measures using the sine law. Remember, in this case, we're going to have to do sine to the power of -1 or inverse sine. So we're going to be doing second function or possibly a shift button on our calculator when we're using a calculator to find these types of questions. So we're going to look at applying the sine law and explaining how to use the sine law. Switch statement is not true about triangle DEF. Can I use the sine law to determine f? So is that true or not true? Well, if I want to find f, I'm going to use the sine law using the formula f over sine of f, which I know to be 32 degrees, is equal to, well, I know all of d. So little d is 24 over its opposite side, which is sine 110 degrees. So in this example, I have all three parts, or I have three parts of the four, I should say. So I can find the fourth if I know all three other parts. So this is definitely true, so it doesn't work for the question. Can I use the sine law to determine E? Well, to find E, I got E over sine E is equal to, once again, 24 over sine 110 degrees. Now, I don't know little e or big E, but I do know the other two sides in my triangle. So to find E, I can say that E, angle E, is equal to 180 degrees minus 110 degrees minus 32 degrees, which gives me an angle measure of 38 degrees. So I can replace angle E here with a 38-degree angle, which means that I do once again know three parts of my sine law, and I can use that to find the fourth. So I am going to be able to use the sine law to determine little e. So that's not going to work for the statement I have. Can I use the sine law to determine angle E? Well, once again, here is what I have. To get angle E, I can rewrite it as sine E over little e is equal to sine 110 degrees over 24. But I don't know little e. In order to find sine of e using the sine law, I need to know little e. And I don't. So this is not possible to do for triangle DEF. I cannot use the sine law to determine e. So this is not true. So this is my answer. And just to confirm, I'm going to look at option D. Can I use the sum of the angles of a triangle to determine angle E? Well, that is exactly what I did right here. So I most definitely can use the sum of the angles to determine angle E. So that is also not what my statement is asking. So my answer is and only could be C. Okay, so we're going to look at this example here where we're going to solve for an angle using the sine law. A surveyor spots a ship that is 2.5 kilometers away. So here's my surveyor, and it sees this ship right here. Her line of sight with the ship makes a 40-degree angle right here with the shoreline. Her assistant along the shoreline spots the same ship, so the assistant is right here, 1.8 kilometers away. What is the measure of the angle at the assistant? So what we're looking for is this angle right here. We don't know how far away the surveyor and the assistant are, but we don't really need to. I'm going to call the unknown, well, I have the unknown angle called x. So I'm going to look for my opposite angle, or my opposite side, which is this one here, 2.5. So to find x, I type in, or write in, sine x over 2.5 is equal to sine of 40 degrees over the opposite side to the 40 degrees, which is 1.8. To get x by itself, I'm going to have to cross multiply, or get sine x by itself first. I'm going to cross multiply. I'm going to get 1.8 times sine x is equal to 2.5 times sine of 40 degrees. So what I do next is I divide both sides by 1.8. And that tells me that sine of x is equal to 2.5 times sine 40 degrees all over 1.8. So sine x, when I put this into my calculator, the calculator I'm using right now, I can type it in exactly as I see it. You have to be familiar with your own calculator, how that works. And also make sure again that your calculator is in degree mode. It either has a D or a DEG at the top of your display, or if you're using a graphing calculator, if you hit the mode button, you should see the degree symbol or the degree word highlighted. So I type in 2.5 times sine 40 degrees divided by 1.8 means that sine x is equal to 0.8928 approximately. Okay, so now to find x, I have to get x by itself. I'm going to bring it up here. X is going to be, I've got to get rid of that sine ratio, so I'm going to do the inverse sine of 0.8928. So x is equal to the inverse sine, so for me I have to hit second sine, and then I type in 0.8928. And then I hit equals, and it tells me that angle x is going to be 63.2 degrees, or approximately 63 degrees. So the measure of the angle at the assistant with the shoreline and the ship is 63 degrees. So to summarize again, and the sine law is used when we don't have a right triangle, and we can find a missing angle measure this time if we know two sides and an opposite angle. We knew two sides and we knew one of the angles opposite in this particular triangle that we just looked at in our example. The sine law for triangle ABC, when we're looking for a missing angle, is sine A over A equals sine B over B, which is equal to sine C over C. And once again, we only need to work with two ratios at a time. We don't need to work with all three. We just need to work with any two parts of our sine law.